Hi guys, so just a heads up, this is going to be a longer video just because I'm going to show you some mistakes to be made. So for instance, if you look at the first problem, sine of 2x plus 4x equals to 0, you'll note that the first thing most people want to do is apply the double angle formula, and that's fine. So I'm going to do so, sine of 2x times cosine x plus, and then sine of 4x. Well, sine of 4x is just another way to say sine of 2 times 2x. So I'm just doubling up the angles in my double angle formula. So it'll say 2 sine 2x cosine 2x. So I'm going to write that down plus 2 sine 2x cosine 2x. Now, if I look at this, the only GCF I have is 2. So that really doesn't do much for me. Because cosine x, sine x, they don't have the same values here because this is sine of 2x, cosine 2x. So when I'm at this point, you could choose to go further. You can actually apply the sum formula here because sine of 2x is known as sine of x plus x, or you can apply the double angle formula here. And for cosine of 2x, again, you could apply the double angle, or you could also apply the sum formula. The sum formula is actually just a proof of the double angle, so either one will work. If I bring everything down, um, it pretty much starts to look a bit overwhelming. But the fact that I've noted that there's no real trig GCF here kind of sparks another idea. So, you have to make your mistakes in order to be able to see certain things. In this case, I'm going to keep the first term sine of 2x plus, and I'm going to change the second term using that double angle formula up above, which will be 2 sine 2x cosine 2x equals 0. Now I actually have a GCF I can factor. So if I look between the two terms separated by the plus sign, the GCF here would be sine of 2x. And if I factor that out, in the parentheses, I'll be left with 1 plus 2 cosine 2x equals 0. This is the ideal situation to solve because when it's factored and the other side is equal to 0, you can use what's called zero product property. So zero product property states that when it is factored, the other side equals to 0, you can set each one equal to 0 to solve for x. Okay, so you cannot get rid of this 2 for the sine of 2x. This is an angle. If the 2 was in front of the sine, that's a different story. But this is an angle. You can't get rid of it by dividing it out. So in order to actually solve for 2x, to find out what that is, I need to look at my unit circle to determine where does sine equal to 0. So sine equals to 0 at 0. So sine of 0 equals 0. That means 2x equals 0. There are more values on the unit circle where sine does equal to 0. So I'm going to continue. Sine of 2x equals to 0. Where else does sine equal to 0? That would be at pi. So sine of pi equals 0. So 2x could be pi. If I continue on, where else does sine equal to 0? Sine equals to 0 at 2 pi. And anytime you're dealing with a double angle or a multiple angle, meaning that x is being multiplied to a number other than 1, go around that unit circle an additional time. So I'm going to find the coterminal angle of pi as well, which means I'm going to add 2 pi to pi, and that would give me 3 pi. In case Module 4 you forgot what coterminal angles are, coterminal angles start and stop at the same place. They're angles that have the same initial point and have the same terminal point, meaning they start and stop at the same place. And the only way that that can happen if you start and stop at the same spot is if you go just a full rotation around. So for instance, if I were to go from 0 to pi, I would start here and end here. The only way I can also start here and end at that same point is if I just went around the circle one extra time and then stop right there. Coterminal angles, you can add or subtract a full rotation as many times as you want. So it doesn't matter how many times I go around the circle, I'll still start and stop at the same spot. Full circle starts at the same place, ends at the same place. So notice for the pi, I just added 2 pi and I got 3 pi. That's a coterminal angle. And then I can divide by 2 to solve for my angle x. So each one of these are values from the unit circle every time I divide by 2. Notice the coterminal angle as well. So if I divide by 2, I'm going to get pi. That's within one rotation of the unit circle as well. So keep that in mind when you have a multiple angle, because you're going to divide by that number. And then what happens is that it's going to be within one rotation of the unit circle. So these are my angles so far. There's more. So if I look over here to solve for cosine of 2x, the goal is to get cosine of 2x by itself. I'm going to move this 1 and this 2, not that 2, this 2. So I'll get cosine of 2x equals negative 1/2. Again, you can't move this 2. So to keep this 2x, I'm just going to find out what it equals to by determining where does cosine equal negative 1/2 on the unit circle. Go into the unit circle again. There are only 2 quadrants where cosine is negative, and that's quadrant 2 and quadrant 3. So cosine equals negative 1/2 at 2 pi over 3 and at 4 pi over 3. And since I have a multiple angle, I'm going to go around that unit circle one additional time, and I'm also out of room, so I'm going to write it up here because I'm out of scrap paper too. 2x equals, so how do I find the other 2 angles? Well, I'm going to go additional time around 2 pi over 3, so coterminal angle for that. So I'm going to add 2 pi to 2 pi over 3. 2 pi over 3 plus 2 pi. So you can either go into your calculator, add fractions, 2 over 3 plus 2, and bring the pi over. I do crisscross applesauce by hand, so 2 times pi is 2 pi, plus 2 pi times 3 is 6 pi, over 3 times 1 is 3. So 2 pi plus 6 pi gives me 8 pi over 3. So that's one of the other angles. And then I'm also going to add 2 pi to 4 pi over 3. Since I already did it, I'm just going to save the work here and tell you it's 10 pi over 3. Now the goal of this is just to get the x by itself. So I'm going to divide by 2. I'm sorry it looks like a real mess here, but hopefully you're following along. X equals 2 pi over 3 divided by 2. Okay, so basic fractions again. We don't divide fractions. We keep, change, flip. So I'm going to keep the 2 pi over 3. I'm going to change it to multiply, and I'm going to flip that 2 over 1 into 1 over 2. And the 2's will divide out, giving me pi over 3. That's one of the angles. If I divide both sides by 2 here, again, keep, change, flip, 4 pi over 3 divided by 2. And that will give you 2 pi over 3. If I go up here and divide by 2, keep, change, flip, x will equal 4 pi over 3. And divide by 2 here. Sorry guys, there's a lot of work to be done here. X equals 5 pi over 3. All of these are within one rotation of the unit circle. So just keep in mind when you're dealing with multiple angles, you might want to add some additional coterminal angles, because when you do divide by the number being multiplied to x, you will end up with other angles.